welcome to All Things Engineering by EIT. This is a podcast where we cover industry insights, emerging trends, and practical knowledge across engineering disciplines.
My name is Dr. Ana Evangelista. I'm course coordinator at EIT. I'm also teaching bachelor's degree unit, master's and supervising doctorate students. And today with us we have Dr. Caroline. Caroline, could you please introduce yourself? As in today's episode, we are going to discuss the critical role of infrastructure planning in a changing climate. That's why we invited Dr. Caroline. Caroline, could you please introduce yourself?
Yes, first of all, it's great to be here. Thank you so much, Dr. Ana. I'm Dr. Caroline Figueiredo. I'm a civil engineer with a PhD in environmental engineering, and I serve as a lecturer at EIT in the School of Civil Engineering. So as a civil engineer and a researcher, I work with different digital tools. So I normally use the building information modeling or the BIM methodology, also digital twins. We can talk a lot about that today. So all of these digital tools aim to support better infrastructure planning, especially in the context of our changing climate. So what we are seeing today is that traditional infrastructure design methods are struggling to keep up with the increasing frequency and intensity of extreme weather events like cyclones, prolonged heat waves, intense flooding. So that's why planning needs to be more forward-thinking. We need to try to anticipate risks, integrate real-time data, prioritize resilience from the very beginning. And that's why my work has been on developing approaches that combine sustainability principles, because my focus has been on sustainable construction, but to combine these with advanced digital technologies to help us design infrastructure that not only performs well under pressure, but also adapts over time, because this is our reality nowadays. And that's why this conversation here today is so important, so urgent, and I'm very excited to be here. Thanks so much.
Oh, that's really great, because this is the main point today, to talk about the impacts of the cyclones on infrastructure and how civil engineers can build resilience. So recently in Australia and New South Wales, we had the tropical cyclone Alfred. So
Yes.
the Bureau of Meteorology reported several floodings on 14 rivers. So it was very difficult situation. The communities in New South Wales, Queensland, and they faced it over during the cyclone time. So disrupted care, and it also difficult related to the health risks, emergency during even during the recovery phase. So many challenges the communities face it. So what do you think about the infrastructure's failures regarding the recent cyclone in Australia?
Yeah, this is a great question, because this tropical cyclone Alfred really exposed a wide range of vulnerabilities in our infrastructure. And as you said, particularly in coastal and regional areas of Southeast Queensland. So we saw widespread flooding, severe wind damage, and even coastal erosion. So all of these topics had serious impacts on buildings, essential systems, and actually we saw many news about the transport sector, because roads were completely washed away, some bridges became unsafe, also regarding power networks. Networks collapsed under the pressure, leaving communities without electricity during a critical time. Water systems were also overwhelmed by the intensity of the rainfall. So I really believe a big takeaway of this cyclone Alfred was the extent of damage caused not only by direct structural failure, but also by water ingress, debris. So some buildings experienced significant structural compromise, not just from high winds, but from prolonged exposure to because of poorly sealed envelopes, aging materials, lack of maintenance. So all of this highlights how much our existing infrastructure was simply not built to handle the kinds of extreme and prolonged events we are seeing now. And this is not the reality just in Australia, but worldwide. So I really believe that this is a wake-up call to reevaluate not only what we build, but how and where we build it. So yeah, I would ask you, do you think were structural failures due to outdated designs, poor materials, or extreme conditions beyond current standards?
Yeah, this is a good question because it's very hard to identify only one factor in order to understand the structural failures. Pretty much it's a combination of factors. Usually it's an outdated design, as you mentioned. Sometimes the quality of materials, the construction of materials are not according to the standards, and extreme conditions. Sometimes we cannot predict how the severe weather will affect any specific region. So, but yeah, we know older infrastructure, normally those types of infrastructure, they are more susceptible to this type of damage. So structures built before the implementation of some cyclone-resistant codes are in high risk. We have here in Australia some recent studies just showing that older buildings, they are more susceptible to structural damage than the new buildings because the modern standards, when they present a new standard, usually they input the new values in order to accommodate the changes regarding the weather and the different types of damage that can occur into infrastructure structures. So yeah, climate change also contributes to the increase of the intensity of cyclones. That's why we need to have the historical data to input in our new standards to accommodate this type of change. So another point that we normally need to consider is how the sectors are affected. I think the drainage systems, we have some limitations in our drainage system. So drainage infrastructure needs to be continuously improved. Also, when you have this type of severe weather, we need to consider all the communication network disruptions as well. So the damage of communications towers. So only when you face this huge challenge, the community realize how communications is super important and affecting because if you don't have communicate, how you can request some emergency services. So it compromises the quality of emergency services and overall the public communication. So Caroline, now I'd like to know more from you. How, as a civil engineer, how do you think the civil engineers design can produce better design when it comes to the cyclone-resistant infrastructure? Do you have some ideas to suggest?
Yes, this is a good topic. Because I really believe that to design infrastructure that can truly withstand cyclones, we need to shift from traditional code minimum design approaches to performance-based design strategies. And this means asking not just whether a structure can survive, but how it will behave under extreme stress. So for example, wind, rain, flying debris, prolonged exposure. And I think you mentioned an important topic about codes, okay? We need to think about that. We need to improve our construction codes to improve the way we construct our buildings, our facilities. But thinking about the civil engineering's perspective, we can talk about different types of digital tools available in the market nowadays that we can use to assist us in improving the decision-making process of our projects. So for example, the building information modeling or BIM methodology, digital twins, these methodologies allow us to simulate the conditions of the facility before anything is built. I don't know if everyone here listening to us know about digital twins, but basically this concept is about having two different facilities existing at the same time. So we will have the digital building, and at the same time, we will have the digital building, and at the same time, the physical building. So both buildings will coexist and feed each other with data and information. So that's the idea. We will test different alternatives, different possibilities since the early stage of the design process. So we can test, for example, structural analysis, we can model a cyclone scenario, we can evaluate weak points and refine the design accordingly before we go to the construction site to really construct the physical building. So this kind of predictive design gives civil engineers a more proactive role in resilience planning. I think that's our point here. And then there is the sustainability angle, because we need to explore alternatives with lower carbon footprints, but that still perform well in harsh conditions. So the challenge here for civil engineers is to balance everything. We need to balance durability, cost, environmental impact, but thinking about this climate changing, because this is the reality worldwide.
100%. Yeah, in fact, how civil engineers can also help to mitigate the issues regarding the flood. So flood resistance. So there are so many researches done under the big umbrella of water management in order to improve the runoff systems. So we have one student at EIT, a doctorate student. He lives in Africa, and he's also working with this type of topic, a framework for sustainable management of a surface runoff in growing urban cities, city centers in Africa. So everywhere, not in Australia, but other countries, we all as civil engineers have something to contribute. So this is another point that we can also highlight during this conversation. We have so many advanced technologies coming to our areas under the big umbrella of modeling and simulation, as you mentioned before, and the remote sensing and GIS. This is the technology we have to monitor infrastructures and access damage after cyclone as well.
Yes, exactly. And not only about that, but also we need to think about the role of material science, because there are multiple construction materials available for us to use, but we need to consider material science in our design process. So reinforced concrete, flexible structures, sustainable alternatives, we need to balance all these aspects. So what do you think about that? The role of material science in this context of cyclone-prone environments?
Yeah, this is a 100% important point to highlight today, because we have new trends in material science, such as modern reinforced concrete. We have ultra high performance concrete. What we are looking nowadays in terms of building materials and construction materials, we want type of structural elements showing higher ductility. Ductility, it helps the overall structure to accommodate the energy and high wind, absorb energy from high winds and impact. So we have lots of research available nowadays under these topics, and new materials comes, innovative materials such engineering cementitious materials, those new types of construction materials. The main point is to present high ductility. It allows materials to show high flexibility and more resistant to crack. This is one of the main concerns when you look at some damaged structures, is about the cracks formation and cracks propagations, because at the end it results in the building collapse or bridges collapse, something that we try to minimize or avoid as much as possible. So in summary, we have some modern techniques, in order to enhance the combination of strength and durability of our materials. So another point that I think is very important under the big umbrella of civil engineering is urban planning. Some urban planning strategies when you have this type of severe weather scenarios to face in our profession. So what do you think about how the cities should lay out? How cities can be better prepared and adapted for those extreme weather? Do you have some suggestions?
Yes, this is another important topic because urban planning plays a huge role in resilience. So it's not just about designing stronger buildings, but it's about designing smarter cities. I think that's our main priority nowadays. So for example, we need to think carefully about where we place critical infrastructure. Are we building in flooding prone areas? Do we have enough buffer zones, for example, wetlands, green corridors to absorb excess water? So there are key strategies we can use. So for example, elevating roads and essential buildings. We can think about decentralizing energy and healthcare services. We can try to improve evacuation routes. But the most important point, in my opinion, is that planning needs to be integrated. Every time I discuss this concept of a smart city, I think that's the most important topic to be highlighted, because civil engineers, urban planners, policymakers, everyone needs to work together. So we need to use the same climate data, long-term forecasts. So we are not working in silos. And I think that's the most important topic, because we have different digital tools available in the market nowadays. It's easier to create integrative and comprehensive projects. So we can use these digital tools not only for building projects or infrastructure projects, but for the whole city, to create this idea of a smart city. But we need actually to have this multidisciplinary approach for us to see the smart city from different perspectives and using this real-time data. So that's why this collection of data is so important. We need to use this type of information. For example, unfortunately, this cyclone happened, but this is our opportunity now to collect data and to improve future projects. Okay, so the idea is not only to create cities that are just livable, but we need to focus on the possibility of creating a city and a smart city and layouts that can deal with these extreme weather conditions, because unfortunately, it is our reality nowadays.
Yeah, and something that in my opinion, something is missing nowadays in urban planning is how to incorporate nature-based solutions. We need to take advantage of, in terms of what is available for different locations. For example, mangrove restoration, when it's possible to restore and protect mangrove forests along the coastal lines. All these approach can mitigate the issue when the severe weather comes. For example, urban forests, right? This is something that we can, if there is no planned urban growth, if it's not well planned, we end up with reducing our urban forests, and at the end of the day, the urban forests, they can absorb rainwater, they can mitigate the urban heat island effect and minimize the climate change affecting the the cities we live. So the other concern is about living shorelines that can incorporate some natural elements to stabilize the coastal lines and to reduce erosion, all this damage that we can identify when a cyclone situation comes to a specific zone or region.
Yes, that's true.
So, yeah, and now we can talk about how we can prioritize critical infrastructure. Let's talk about this now.
Yeah, of course. I don't know. Do you think there is an infrastructure system that we need to focus on first? What do you think about that?
Yeah, when it comes to building cyclone resilience, when you think about civil engineers, how we can prioritize the infrastructure, we need to think about the public safety, we need to think about emergency response and the post-disaster, because it's not only when the cyclone or any other severe weather occurs, but what happens after this. So in terms of the emergency response and healthcare infrastructure, we need our hospital and medical facilities. When we design this type of buildings, we need to think about the structural integrity. One of the main points we realize when you have the post-cyclone, it's about the redundant power or a redundant water supplies as well, because those are the most important sources of supply. We need energy supply and water supply. And yeah, we need to think about the bridges and roads, right? Those are essentials in terms of emergency response. That's why the strengthening bridges and roads, be more careful when we're designing bridges and roads, taking into consideration the severe weather loads as inputs and impacts and winds load. So this can ensure that in a very difficult situation, bridges and roads, they are critical to connect the communities, to facilitate the emergency access. So yeah, in summary, in my opinion, when it comes to prioritize, it's about the power grid, it's about the water system, and ensure reliable communication, for example, satellite communication, right?
Yes.
This is the potential solution when you need to ensure the communication continues, even though if you don't have a power, this is some alternatives.
Yes, that's true.
So, Caroline, and what about, this is some difficult topics to mention, but how the government policies and funding can affect the decision makers into civil infrastructure projects? Do you have some opinion formed around this topic?
I agree that this is challenging sometimes to talk about that, but this is very important because government policies and funding create the framework within which civil engineers operate. So the idea is that basically the government policies will set the parameters for project design, construction, operation. So they influence the allocation of resources, and we need to consider that in our situation. So I really believe even if engineers design high-performing, climate-adapted infrastructure, we need political will and financial investment to make those solutions a reality. Okay, so short-term funding cycles can be a barrier because resilience often requires long-term planning and upfront investment. But we are starting to see more recognition that investing in resilient infrastructure saves money in the long run because we will reduce disaster recovery costs. So policies that promote proactive planning, for example, hazard mapping, climate adaptation strategies, infrastructure audits, this can help guide better decisions. So funding mechanisms need to support not just rebuilding, but rebuilding better and improving the idea of future projects. So we need to consider the role of building codes, the role of building regulations in disaster resilience.
Yeah, because we needed to ensure structural integrity. This is no doubt one of the critical points, and the building codes establish the minimum standards for the structural design. So the life safety also relies on the codes, including provision for not only in cyclone situations, but in the fire situations. So for fire safety or safe occupants, all these under these life safety codes provided. So also we need to think about how to promote resilient construction practice. It's about, we talked before in relation to material selection, the codes, the role of the building codes and regulations are critical when you think about disaster resilience. So when you think about the post-disaster recovery, we need damage assessment. So the codes again plays an important role, providing clear guidelines in order to ensure that we can evaluate properly the structural integrity and identify the necessary repairs. So, yeah, we also need to think about how innovations, engineering innovations, and can help to improve and to increase disaster resilience. Do you have some ideas how smart materials of nowadays is all about artificial intelligence, tools for structural analysis, and how modular constructions can contribute to mitigate the impact?
Yeah, this is another great question because actually I really believe there is a wave of innovation happening right now in civil engineering that is very exciting, especially when it comes to resilience, because we are seeing the rise of smart materials that can adapt under stress or even self-heal after damage. And this is amazing. So the use of fiber reinforced composites, high performance concrete, flexible building systems. So these are some examples, but there are multiple others. And on the digital side, we can use technologies like artificial intelligence to help us analyze the structure performance in real time, or even to predict where failures might occur. And this is amazing as well to avoid problems in the future. And another powerful tool is digital twins, as I said before. So we can create a virtual replica of a building or a system and simulate how it would perform during a cyclone, for example. So this means we can spot vulnerabilities before they become real-world problems. And that's the main point here, is to improve disaster resilience using this type of technology to improve our decisions before the problem really occurs. And as you mentioned, there is also modular construction, which is gaining ground in disaster recovery because it allows for faster, safer, and more efficient rebuilding, especially in remote areas. So there are many benefits associated with the use of modular and prefabrication construction.
Yeah, and there are so many lessons learned from different countries, such as US, United States, or Japan, or Philippines. Are there any lessons learned from the previous situations across those countries that we can apply in Australia?
Yes, for sure. So I think lessons learned is an important topic when we are talking about any kind of project. We always talk about lessons learned when we are talking about project management. And this is also the reality when we are talking about a cyclone or extreme events like this. So each of those countries offers valuable lessons. Japan, for example, is a standout when it comes to strict building codes. And they also focus on early warning systems, public preparedness, So they really created earthquake engineering principles that also apply well to cyclones, especially in terms of flexible yet robust structures. Okay, you also mentioned Philippines, and Philippines has made advances in community-based disaster preparedness. So they have designed low-cost and cyclone-resistant housing and working closely with local populations, which is amazing as well. And in the US, particularly in states like Florida, we see the use of reinforced concrete block construction, elevated structures to handle flooding. So there is this strong integration between meteorological data and infrastructure planning. And I think Australia already has a strong engineering base, but we can do more to integrate these global insights, especially in policy, community engagement, innovation uptake, because I think we always have things to learn from other countries, from other locations, to avoid having the same problems, the same negative results. We need to use these types of lessons learned to improve our future projects.
So, thank you. Yeah, Caroline, I think this is very good point when you talked about the community engagement, because civil engineers will play a super important role in order to enhance the community's preparedness to tackle this type of severe weather and the types of disasters that occurs. So in my opinion, I also consider very important how the civil engineers can communicate with the community in order to get the early involvement, in order to provide the community with the clear risks associated with, for example, cyclones in recent situation in Australia, and involve communities into the participation, into the just when they are doing the designs for any specific location and specific community. All this combined, it can lead to more effective, I believe, and culturally appropriated solutions. Otherwise, you can have a great plan, but if the community is not involved and is not educated as well. So that's why this is my second point. It's about education and awareness, because we need to get the community trained and be prepared to those type of disasters. For example, providing first aid training or emergency communications training and shelter management. So we need to when it comes to these situations, the community acts in order to help each other to go through those types of challenging times. So, and the other point that I was wondering that we can also discuss here is if you just can briefly talk about the biggest change in civil engineers, how we could push for in cyclone-prone regions. What the biggest change that we need as civil engineers to keep in mind in order to get prepared for those type of extreme weather conditions?
Yeah, first of all, I think we need to change this mentality. I totally agree with you when you said about community involvement. This is critical. And when you were saying, I was thinking about my lectures at EIT, because I always talk about that to the students, because engineering can't happen in isolation. We need to design with people, not just for people. So we need to listen to local knowledge, understanding specific vulnerabilities, and making sure infrastructure is culturally appropriate, accessible, and clearly communicated. So I think we still need to change this in our mindset as civil engineers worldwide. But regarding your question about how to push for in cyclone-prone regions, if I had to choose just one biggest change, I would say we need to embed climate risk assessment into every stage of infrastructure planning and infrastructure design. So it includes using current and projected climate data, not historical averages, as the baseline, because resilience shouldn't be an optional upgrade. It should be the default. We are seeing this reality, this climate changing worldwide, and we need to consider resilience, sustainability in our construction projects, because unfortunately, the construction industry is responsible for a huge amount of environmental impacts and also economic and social impacts. So when we are dealing with this kind of extreme event, the way we develop our built environment will directly affect the lives of the people. So we need to focus on that, to embed climate risk assessment during the whole process of the infrastructure planning and design.
Yeah, I really appreciate your thoughts, Caroline. And today it's not an academic discussion, even though we are both teaching at the EIT. We are doing some research at the EIT as well, but it's about real lives and real communities. That's why this topic is so important. And I have some takeaways to summarize what we discussed today during this podcast. I really encourage our listeners to stay informed. It's important to keep yourselves up to date on the last research, building codes, and climate projections in your region, in your area, in your country, in Australia, but not only in Australia, overseas as well. Also, it's very important to not be afraid to voice your concerns to local authorities, and we need your voice makers, right? Your voice matters, and that's why we need to keep our government aware about projects needed in our region, in our area. So it's also important not only to wait for others to solve our problems, but to get involved in local community. So offer your skills, right? Engineers, we have a lot to offer. We need to keep an eye on the United Nations Sustainable Development Goals. We have 17 goals that we can contribute as engineers, not only civil, but mechanical, electrical, industrial automation. So engineers, to have a huge responsibility in our hands. So, and finally, if you found this conversation valuable, please subscribe to our podcast. We'll be continue to bring you expert insights and discussions in critical topics around the civil, or not only civil, but our other engineering areas. So by subscribing, you're going to stay informed, empowered, and part of our community that's working to build a safer future. So this is our main point today. So I really thank you, Caroline, to join this conversation, and thank you all for listening. And remember, preparedness it's not just a project, but it is a responsibility we all share. So thank you all for listening. Bye.
Thank you so much. It was a pleasure. Bye-bye.
Thank you so much for tuning in today. If you enjoyed this episode, make sure to follow and subscribe, and so that you don't miss future conversations. We've got some exciting guests lined up and a lot more to share. So do connect with us on social media and share your thoughts, questions, or experiences. So until next time, stay curious and keep pushing boundaries. Thanks, everyone.